In this section 9.5 vertical motion under gravity, where we discuss an object moving vertically downwards. So what kind of forces is going to affect and what is the acceleration? As we know that the forces the object uh, fall freely because of the gravity. So gravity. So gravitational force. Acceleration due to gravity is denoted by g usually. So g can be 9.8 or sometime it will round up to 10. It is depend on the sum. Usually it is 9.8. And in this section we don't consider that any air resistance uh, of the opposed to the falling direction. Assume the 1 kilogram box or 2 kilogram box, 2 kg box, and 200 kg box is falling down. It's a free fall. So they have the both different forces. If we put F equal ma downwards, so this is going to be, let's say, the force F1 and this is F2. So F1 is 2 times G and F2 is going to be 200 times G. So this force is higher, lower than this force, but the gravitational force is still the same. So F1 2 times 9.8 and acceleration due to gravity is same. It does not depend on the size of uh, the mass of the object, but it has two different forces. So what usually with the horizontal motion we will give that okay the particle is moving from 2 meter per square second, the acceleration is. But if it is a free fall, so we can assume that that is 9.5 ms minus 2. And as I said, the air resistance we usually disregard. This F1 is the weight actually, weight of the um, object. And when we work with this chapter, we use normal equations S equal ut half at square and v equal u plus at. Basically all the equation we derive from the velocity time graph. We'll discuss the example, then you will see that how we can apply those equation into a vertical motion. And this is very easy, nothing much, no difficulty, no complex calculations. And example 10. These equations are vector equation, is they require a direction. Example 10. A book fall off the top shelf of a bookcase. The self is for 1.4 meter above wooden floor. Find the time the book takes to reach the floor. B, the speed with the velocity to strike the floor. So first of all, so this is the bookshelf. So this is 1.4 meter, and a book usually we denote by a particle. This is the floor, and so this is falling under gravitation. Then okay, this is when it start this particle or the book. U is 0. So U is 0, M is minus 1. Now distance. Um, we'll take this side is as mentioned in the book positive. So then this is going to be 1.4 meter, and what else? Uh, Acceleration is 9.8. We know that acceleration is downward, so that is positive then. Positive 9.8 ms minus 2, and we need time. So we can put S we know, U we know, T we need, A also we know, then only we can find T from here. So from S equal UT plus half AT square. So S is to this direction 1.4 equal U times 0 times T plus half a times 9.8 times T square. So this is going to be 2.8 equal 9.8 T square. So T square equal 2.8 divided by 9.8. T equal plus or minus 2.8 divided by 9.8. We need to take the positive ones as time can't be negative. And this is 0.5345. If you put this side is positive, what will happen when you apply the equation? Um, we can apply to upwards the equation. Then this is going to be a same, and this is going to be negative. Minus 1.4 times minus 0 point times t, then half a times minus 9.8 because it is putting up upwards, and t square. So minus to minus cancel, and still you get the same answer. Part B, we need to find the speed when we strike the floor. So then we have V, we need to find U, we know 2, and A and S. We can work with this one. So V square equal U square plus 2AS. When we put downward this equation, V square equal U square is 0 plus 2 times the gravitational force downward, that is 9.8 times S also 1.4. So V square equal 9.8 times 2.8. So V equal square root 9.8 times 2.8. So this answer is going to be 27.44 square root, and 5.238. So approximately 5.242 SF. This is a free fall from this book. So because of that, it is U equals 0. Example number 11. A ball is projected upwards from X, which is 7 meter above the ground, with the speed 21. We need to find the greatest height above the ground reached by the ball. That's the first one. From here, uh, this kind of this is 7 meter. Um, the ball is projected upward. You know that when you project a ball, it will go up and it will come down. The same thing, but since this is projected from a place, high place, from a platform, so it will go up and stop and change the direction and come back. It will come like this. Usually we draw this journey as something like this. A ball start from here. So S, the distance usually we define from the particle place where the particle move. So this is the x-axis and I stay with this one. So this side is positive. We'll take this side is positive. And at so V value is 0 when it's at the maximum height, and the projection speed is 21 ms minus 1. So u is 21 ms 1, v is 0 because before it turn the velocity becomes 0, and s is given s we need to find, and a is 9.8 to this direction, ms minus 2. So we need to find the height from here to here height. So we can find with that with this equation, v square equal u square plus 2as, then is equal v square minus u square divided by 2a. So v square is 0 square minus u mean 21 square over 2 times. Now we will put this one to this direction, this equation. That's why u value is positive. This is plus positive 21 square. This negative come from here, from the equation, not because of the direction. So u is positive for here, and v is no direction. So you can take up or down because it is 0 value, it doesn't matter. And a is this direction, and s we are going to get upward answer then if we put the equation upward. So s equal minus 21 square. Okay, this is going to be negative 9.8. This is going to be 441. Negative 441 divided by negative 19.6. So answer is going to be 22.5 meter. So from here to here, the distance is 22.5 meter. Then maximum height from the floor, from the ground. So we have to add this 7 as well. Um, max height is 22.5 plus 7, 29.5 meters. The next part is the time of the flight. Time of the flight means the whole journey when it start until it's finished. That's the time of the flight. Usually we refer that time of the flight when a particle project. The time it stay in the sky. Um, or the best word is air. So V equal is still the same. So now this V is not valid as it is valid, but we don't need that because we are considering whole journey. So we have two data, but this equation we need time. So we don't know the hitting time, hitting speed. So this is invalid then. Then only possibility is this one. We know U, we know A, and the S we know the distance because when it hits, this is 7 centimeter, the height. So it start from here and the direction is here. So this is minus 7 meter from this point. So this is the uh, x. Let's say x and y. Usually we don't like the mark x and y, but for you understand, so it's go up and now you can see that it is minus 7 downwards from this place. So from this plate is up and this is down. So this is minus 7 meter. So we have now 3. Then we can find t. So s equal minus 7. U equal, okay, which side we are going to put this s equal ut plus half at square. We'll put this side because usually it is better to put always the where the direction of u. So S is minus 7 because particle move here and this is the positive direction and this is the starting. So it is minus 7. So we are putting the equation upwards and U is 21 times T plus half. Now the gravitational force is downward. So if you want to make upward, then what is the answer? Minus 9.8 t square. Then multiply by 2 or divide by, so minus 7, 21t, 4.9 t square. So 4.9 t square minus 21t minus 7 equals 0. Then we have to use the quadratic equation t equal minus b plus or minus b square minus 21 square minus 4 times a 4.9 times minus 7 divided by 2 times a 4.9. So approximately this is 4.5965 4.9 5965. I'm taking the answer from the book. So 4.642 SF. It is better to consider always the place where the ball throw the particle through the x-axis. X-axis should go through the starting point of the particle. It is a recommended way of doing this. Question number 12. A particle is projected vertically upwards from a point O with the speed u. The greatest height reached by the particle at 62 meters above from O. Find the value of u. So it is also throw and come back again. So we can't draw that one like this. So we are just adjusting bit. So let's go like this and come back like this. This is the O. This is thrown with U, ms minus 1. This height is, maximum height is given 62.5 meter. Now U is actually U, and S is 62.5. It's depend on the journey you select. The first question is find the value of U. So then we have to consider, let's say this is AB. So consider AB journey. For AB journey, U is U. So if you want U naught is U ms minus 1, it's up to you. And V is, we know that 0 ms minus 1 at top, and S is given, so this is the positive side, 62.5. So U is this direction, we can write as this direction, it doesn't matter, it's 0. And now we need to find U. So V square equal U square to AS. A is this direction minus 9.8 ms minus 2. So we'll write SC V square equal U square plus 2AS to this direction. 0 U square is U square, and plus 2 times A is 9.8, and S is given 62.5. So U square equal, so I'll bring to everything other side, and 2 times 9.8 times 62.5. So U square equal 1225 from the book, and you will get you 1225, that is 35 ms minus 1. Now we have a good data. This U value is 35 ms minus 1 meter per second. Part B is the total time for which the particle is 50 meter above or more. So this is 50 meter. So basically when we calculate the particle, the time particle go to 50 meter, so we will get two answers. One is T1 when it is going up, and then the second one when it's coming down. So the time it stay more than 50 meter is the time in this curve. It means T2 minus T1 times the particle stay above the 50 meter. So basically we are going to find from how long it will take particle to go to 50 meter. Then for that answer, we will get two answers for that equation. So we'll consider we need time t is equal ut plus half at square to upward. H is 50 meter, u now we know 35, and t, so this t is the time that the particle takes travel to 50 meter, times take to travel 50 meter, and half a times upward is 9.8 times t square. So this is going to be 50 plus 35t minus 4.9 t square. So I want to make this positive. I'll bring to this side 4.9 t square minus 35t, and this is plus 50 equal 0. From the quadratic equation, t equal minus 35 plus or minus b square minus 35 square minus 4 times 8 times c divided by 2 times 4.9. Then you will get t value, two t values. One is t equal 5.1686, 5.1686. The other t value is 1.97, 1.9742, 1.9742. So the small time is, little value is when it's from journey to here, the time taken, and this one 5.86 from here to up to here. Then when you take this difference is the time that the particle stay above 50-meter level. So then let's say this is T1 and T2. T1 minus T2 equal 5.1686 minus 1.9742. So this value will give 3.194, approximately 3.194. For 3 too significant, it is going to be 3.2 to 2 SF. Example 13. A ball falls vertically from the top. A tower 63 meters high. At the same time, so it is 63 meters as mentioned. A ball fall vertically. So from here, the particle is moving. And at the same time, another particle is projecting upwards. So this is 21 ms minus 1 on the starting point. And this is the starting is 0 ms minus 1 to, let's say, this direction. This is the upward. And we are going to work this sum separately. At the same time, as A begins to fall, another ball B project vertically upwards from the bottom tower is between you. The ball collided. So the balls collided in this place. When the ball collided, so one requirement is they travel the same time. If this is t, this is also t, but it has two different distance. So this distance may be s1, this distance may be s2, but s1 plus s2 is 63. Now we can apply s equal ut half a t square to this ball, I think it is A, for ball A, considering S is S1, it's as it is, U is 0, M is minus 1, A is 9.8 downward, and that's all. So this distance is S1. Let's say S1 distance, S1 equal U is 0 times T plus half a 9 point times t square. So S1 equal 4.9 t square. So at the same time, t is projecting upwards. So for t, sorry, a is projecting up b. So s equal ut plus half at square for ball b. We'll put upward. U is 21 to this direction. Will the equation to this direction, and S2 as it is. What else we need? A is minus 9.8, M is minus to this direction. So S is, now this distance is S2, U21T minus plus half minus 9.8 T square. So S2 equal 21T minus 4.9 T square. Now S1 plus S2 equal, we know 63. Now from here S1 is 4.9 T square plus S2 is 21 minus 4.9 T square equals 63, and this is cancel out. This is T. 21T equals 63. T equals 63 divided by 21, so 3 seconds. So ball collided at 3 seconds after they projected. The last part is find the distance of the point where the balls collided from the bottom of the tower. So from the bottom of the tower, it means S2. We can get S2 is, yeah, we will do with the S2. So S2 equal 21T minus 4.9T square. So 21 times 3 minus 4.9 times 3 square. So 21 minus 3, then 4.9 times 9. So that is, the time is going to be 18.9 meter. This distance is 18.9 meter. Ball collided from 18.9 meter.